All right, let's pick up at number 13. Number 13 says find 5/6 parentheses -4 times 2/7. Write your answer in simplest form as you should with all fractions. What is the 5/6 doing to those other numbers? Multiplying. So I know order of operations says start in the parentheses. That's pretty obvious, right? But if this is all multiplication, does the order in which we do it in matter? No. So if it's all multiplication, I don't even have to worry about the parentheses. I can just write 5/6 times, how do I turn 4 into a fraction? 4/1 times 2/7. Now, how many negative numbers are there? 1. Any negative for that one negative to pair up with? No, so the answer is going to be negative. I can check that right away before I even do anything else. Does anything cancel before I start multiplying? The 4 and the 6. Could the 2 and the 6 cancel? Just out of curiosity. Absolutely. The rule states any top number with any bottom number, even if they're over here and over here. Right? But I heard 4 and 6. That's fine. What number goes into 4 that goes into 6? 2. 2 goes into 6 3 times. 2 goes into 4 2 times. And what else can I cancel? Nothing. Yep, I'm done. I've canceled all I can do. So when I multiply now, my answer will be reduced. What is 5 times 2? 10 times 2. 3 times 1 times 7. And remember we said it was negative. Negative 21/20. That's reduced because we canceled as much as we could. Number 14. Ooh, interesting. Find the absolute value of -3/5 plus 3/4. Now, absolute value, what does that do again? What's absolute value do, Georgia? It's exactly what it does. It's how far that number is away from 0. And because it's a distance, can it ever be negative? No, it cannot. So the absolute value of -3/5 is just +3/5. Yeah. In fact, the absolute value of every number except 0 will be positive. Because the absolute value of 0 itself would just be 0. Because 0 is not any far away from itself. It's the same number. Now, do I have to have a common denominator when I'm adding? Yes, I have to. There's no other way around it. What is my least common denominator going to be here? 20. Good. Yep, when I'm adding or subtracting, I need a common denominator, not when I'm multiplying or dividing. That's why I like multiplying and dividing better. Like the last one we did. Now, in order to change the first fraction to a denominator of 20, I have to multiply by 4/4. What's 3 times 4? 12. And for the second fraction, we had to multiply 4 by 5. So what's 3 times 5? 15. And what's 12 plus 15? 27. 27/20 is a great answer. It is not going to work on big ideas though, because their instructions specifically ask for a mixed number like they did a lot yesterday. And so how many times does 20 go into 27? With how many left over? That's right. Just so you guys are aware, and I know I said this a lot yesterday, I will accept 27/20 on your test on Friday. I'm okay with improper fractions. Don't feel like you have to change them back to mixed numbers unless Big Idea says they need it for the answer. Number 15. Here's what we're going to do for number 15. I want you to write A, B, C, and D down. And all they want you to do for number 15 is tell whether it would be a positive or a negative answer when I multiply or divide these numbers. So on Big Ideas, they'll want you to drag and drop into the proper box, but on your work paper, we can just either write positive or negative. Let's look at the first one, which I'm calling A. What will I get when I do a negative divided by a negative? Will those negatives pair up? Yes, they will. That'll be a positive answer. So drag the first one up into the positive box on Big Ideas. For the second one, what's a positive times the absolute value of a negative? It is positive. because the absolute value of negative 2.16 is positive 2.16, and I'm doing really just a positive times a positive. Example C, what will I get when I multiply a positive times a negative? Negative. So drag that one up to the negative box. And then for D, the absolute value of a negative divided by a positive. It's really just positive divided by positive, which is positive. That's right. Oh, that was number 15. Number 16. Georgia, could you shut that door for me, please? It's just kind of getting distracting. Number 16 says 3/8, and we know that means multiply, times 3/4 plus 5/6 minus 1/2. Now, this time the parentheses are important because instead of being all multiplication, we have a mixture. So we really do need to start in those parentheses here. So as I'm jotting this problem down on my work paper, remember, you have to have a common denominator when you're adding. So you might as well just figure out what that common denominator is going to be right now. What's the lowest multiple of 4? That's also a multiple of 6. 12. Nice job. You could have made an argument for 24, and I would have said 24 would work, but it's not the lowest, which means you definitely would have to reduce it. Now, in order to get 12, Ashlyn had to do 4 times 3. So what's 3 times 3? 9. And you had to do 6 times 2. So what's 5 times 2? 10. So starting in the parentheses first, 9/12 plus 10/12. 19/12. And that's reduced. I don't need to do anything with that. Now, does order of operations say after the parentheses that I would multiply or subtract next? Multiply next. So I'm going to focus on the multiplying here. Okay, just that chunk. Before I multiply these numbers, do I need a common denominator? No. Instead, I'm going to try to cancel. Does anything cancel? 3 and 12. What goes into 3? That goes into 12. 3. 3 goes in itself once, and it goes into 12 4 times. Okay. I'm running out of room. Let's shift this over here. What is 1 times 19? And 8 times 4? 32. Oh, did the 8 and the 4 cancel? Can I cancel 8 and 4? Why not? They're both on bottom. It's right. It's got to be a top bottom canceling. Okay. Now I'm going to subtract away this next fraction, which is 1/2, but let's find its common denominator. What's the first multiple of 2 that's also a multiple of 32? 32. What do you have to multiply 2 by to get it to change to 32? Excellent. So 1 times 16 is going to be 16. And if you reduce that, you get 1/2. We're not going to reduce it because that'd be counterproductive. We want to use these common denominators to subtract. What's 19 30-seconds minus 16 30-seconds? 3 30-seconds. No, Branson, it's not 3 32ths. Yeah, 3 30-seconds. Just kidding. Branson's smarter than that. And that's going to be your answer for number 16. Number 17. The table shows the elevation of 4 mountains. Which of the mountains are taller than Snowy Mountain? Blue Mountain, Cascade Mountain, or Brook Mountain? Or a combination of the 3. Maybe they're all taller. What we have here is a chart that has a mixture of fractions and decimals. Now, when you're comparing fractions and decimals and trying to find the least one and the greatest one, is it easier to leave them as fractions or change them to decimals? It actually is easier to change them to decimals because in order to compare those fractions, I would need a common denominator that works for all 3, plus change that to a fraction. That would actually be 7/20. So now I have to find a common denominator that works for 7, 15, 8, 20. Good luck finding that. It would be easier to convert them to improper fractions, or to, to decimals, to convert these improper fractions to decimals. Let's start with Blue Mountain. To turn a fraction into a decimal, I do top divided by bottom. Normally, when you put the top number inside the box, it's smaller than the outside number, but this one's not. That's because what type of fraction is this? Improper. Yeah, the bigger number is, the top number is bigger than the bottom number. It's improper. So 7 will actually go into 9. How many times? 1 time. Gives us a remainder of 2. I'm going to drop down a decimal point. Actually, put 2 decimal points. Drop down to 0. 7 goes into 20. How many times? Twice. Yep, almost 3 times, but not quite. That's 14. 20 minus 14 is 6. Drop down another 0. 7 goes into 60. How many times? 8 times. What is 7 times 8? 56. Let's scoot you over here a little bit. That's a difference of 4. Let's go one more, because this is probably going to keep going, but we'll just go ahead and stop it. We'll round it. We'll round it. 7 goes into 40. How many times? How many times? 5 times. What is 7 times 5? So just in case, I'm going to leave it right here with a remainder of 5. Haven't dropped down another 0 yet. I'm going to put a dot, and a dot just to show that this would keep going. But I don't think we're going to need it to keep going. Like, in order to figure out which one's bigger, I've got 3 digits already after the decimal point. That's probably enough. Let's move on. So we're going to call it 1.285. And we'll move on to the next one, which is Snowy Mountain. Now, does anyone remember what 1/5 was from yesterday? Hannah? 0.2. So that's easy. This is 1.2. That's why I really think you guys should memorize your fifths. 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8. If you didn't, or if you forgot, then remember you would do 1 divided by 5. 5 doesn't go into 1 because it's a proper fraction, but it does go into 10 twice. There's your 0.2. And then you attach it to the 1 that's already here and make it 1.2. Let's go to Cascade Mountain. Cascade Mountain is 9/8. 9/8. So it's another improper fraction. So when I do long division and put the top number inside, top divided by bottom, 8 actually goes into 9 this time because it's improper. How many times 8 go into 9? Once. Gives you a remainder of 1. Put 2 decimal points and drop down to 0. 8 goes into 10 how many times? Once. Okay. That's 8. It's a difference of 2. Drop down another 0. How many times 8 go into 20? Twice. That's 16. That's a remainder of 4. And this would be exactly 5. So I was going to go to 3 decimal points anyways. And so that works out nicely because it is exactly 3 decimal points. It's 1.125. So this long division is really all I need on my work paper for number 16. I think it's 16, 17. To answer this question on big ideas, though, let's reread it again. It says, which of the mountains are taller than Snowy Mountain? Now, some of them have 2 decimal places, some of them have 3 decimal places, and some of them have 1 decimal place. So in order to compare them, it might be easiest just to make them all have 3 decimal places. I could make this 1.200. I could make this 1.350. Just to make it easier to compare. Which of them are taller than Snowy Mountain? So this is Snowy Mountain. Is 1.285 ... bigger than 1.200? Yes. So Blue Mountain is taller than Snowy Mountain. Cascade Mountain, is 1.125 taller than 1.200? No. Brook Mountain, is 1.350 bigger than 1.200? Yes. And really, when I'm comparing decimals, I only have to look at 1 decimal place in this one. The 3, 1.3 is bigger than 1.1, 1.2, and 1.2. So I know this one's not only bigger, it's the tallest. It's the tallest one up here. So I'm going to check Blue Mountain and Brook Mountain as the two mountains taller than Snowy Mountain. Number 18. The table shows the change in the amount of gallons of gasoline in a car over a period of 5 days. What is the total change in the amount of gasoline in the car over that 5-day period? Write your answer as a decimal. What does it mean when it shows the number as negative? What does it mean that it's a negative change? It's what? We lost that. How do we lose that gas? Did it fall out of the tank? Just driving, right? Use it while you drive. What happens on day 4 then? I filled it up, or at least put some more in, right? Yeah. So why don't we do this? Why don't we start? If we look at day 1, 2, 3, and 5, those are days we used gas on, or at least the overall change was negative because we used more than what we had put in. And day 4, we put in some. So why don't we start by adding these 4 negative numbers together? Of course, when we add negative numbers, if they're both negative or all negative, we join forces. This is going to make a really big negative number. That's going to tell us how much gas we used on these 4 days. So we're going to start by adding 1.05, 1.20. Yes, I do need to line up my decimal points because I'm adding 0.85 and 2.15. This will tell me how much gas I used on these 4 days. What is 5 plus 5 plus 5? 15, carry the 1. 8 and 2 makes 10, plus 1 plus 1, 12. 1 plus 1 plus 1 plus 2. Okay. And because I'm joining forces with a bunch of negative numbers, it's going to be still negative. So that's still negative because it represents all the gas that I used. It's not there anymore. Now, on day 4, I put in 10.5 gallons. If I know I used 5.25 gallons, what should I do with these 2 numbers to figure out what my overall change is? Subtract them. Take 10.5 or 10.50, subtract away the 5.25. Can't do 0 minus 5, but we can borrow, make it 10 minus 5. What's 10 minus 5? 4 minus 2? 10 minus 5? Okay, so 5.25, and then it's a story problem. What was I talking about? Gallons, and you can abbreviate gallons, GAL. And that's going to be positive because I put in more gas on Thursday than what I actually used. What's interesting is we get 5.25 again. 5.25 is how much gas we had, or we used. 5.25 was actually not, it's kind of coincidence here, but it was actually also the amount of gas that was the overall change. So we have 5.25 more gallons of gas than what we started with on day 1. Number 19, a person who is 5.8 feet tall is standing in a pool. The top of the person's head is 1.6 feet above the surface of the water. How deep is the pool? Well, if you need an illustration, this is me with my biceps showing because sun's out, guns out, right? Yeah, that's not realistic. I think the stick arms were actually more realistic for me. I'm not a bodybuilder, right, Branson? You know me. Okay. The water is going up to, I don't know, about here on me because it says my head is sticking out 1.6 feet above the water. But it also says that I'm 5.8 feet tall. Let's do this. This is probably the best way to do it. So how do I find out how tall the water is, or what the how much water is in the pool, how deep it is, knowing that my head is sticking out 1.6 feet above the water? Hannah? That's right. That's right. Take my height, subtract away the portion that's sticking out of the water, and whatever's left over is how deep the water is. What's 8 minus 6? 2. 5 minus 1? And 4.2 water. What's my label? 4.2 waves? Feet. That's how much the water, the surface, that's how deep, I should say, the water is from wherever it was on me to the bottom. 4.2 feet. And that takes us to our last one, number 20. The table shows the balance in dollars of a bank account each month for 3 months. What is the average balance of the account? Now, what does average mean? Georgia? Add them all and divide by 3. That's correct. Now, do I always divide by 3? Okay, yep, add them all up and divide by however many I have. In this case, 3 months, I'm going to divide by 3. So I need to add, and I know this is going to be a pain because they're sitting right there staring at you, but I need to put it on my paper. 1,285.12 plus month 2, my account balance was 961.36. Make sure you're doing a good job of lining everything up. Oops, I put the plus sign too early. I need a third number. And then 1,132.63. So when you find the average, or what's also referred to as the mean, you add up the numbers and divide by however many there are. There are 3 months. There are 3 numbers. I need to divide by 3. I didn't do a very good job of lining up my decimal point, my digits. I'm gonna try to. There we go. What's 2 plus 6 plus 3? 11. 6 and 3 and 1 makes 10, plus another one. 11. Drop down your decimal point. What's 1 plus 5 plus 1 plus 2? 9. 8 plus 6 plus 3? 17. 9 and 1 makes 10, plus another 1 and 2? 13. 1, 1 and 1? 3. So if I add my account balance up for these 3 months, it was $3,379.11. But my next step is to obviously divide that by 3. Oops, let's drag you down a little bit more. And the first thing I want to do is not that I have to, but I kind of want to see if 3 goes into this number. So an easy way to see if 3 goes into a number is to add all the digits up and see if 3 goes into that number. I think you guys have heard this before. So let's try it. What's 3 plus 3? 6. 6 plus 7? 13. 13 plus 9? 20, 22. 22 plus 1? Plus 1? Does 3 go into 24? So 3 is going to go into this decimal evenly. That's nice for us to know. How many times does 3 go into itself? Once. That's going to give me a remainder of 0. Let's skip that part. How many times does 3 go into itself? Once. That's going to give me a remainder of 0. Let's skip that part. How many times does 3 go into 7? Okay, that's 6. Gives me a remainder of 1. Drop down the next digit. How many times does 3 go into 19? Hear that? 6 times. Thank you, Aiden. What is 3 times 6? 18. That's a remainder of 1. Don't forget to float up your decimal point. This would be a good time to do that. Thomas, is that your brain clunking around up back there? Somebody's hammering something. 3 goes into 11 how many times? 3. What is 3 times 3? All right. Okay, that's a remainder of 2. And then drop down the last digit. And how many times does 3 go into 21? And that's exactly 21. So that's going to give us a remainder of 0. Just like we said, it's going to go in evenly. And so what was I talking about here? What does this number represent? Dollars. Yeah, put your dollar sign, and we know the dollar sign goes in front of the number. And so $1,126.37 is my average account balance. That number would be right in the middle of these 3. So you should have all 20 questions done now. In order to get the extra credit for this, I need your work papers. You have until Thursday to get these work papers to me. So if you need to watch the first video or even part of this video because you missed something, feel free to do that. And you have until Thursday, like I said. If you're ready to turn them in right now, make sure your name's on them and come put them up here on my podium.